All right, hi. Welcome to R2E, and this is me, Raman. And again, in Kleppner series, we are trying to solve problem 3.1 from Daniel Kleppner and Kolenkow. So what my problem says that I have two identical masses M right here are pivoted at each end of a massless pole of length L. So you have this pole and they are now pivoted to it. The pole is held leaning against frictionless surface. There is my photo. Huh. Okay, so at an angle theta. So here you have an angle theta as shown and then released with the initial acceleration of each mass. Okay, so uh, frictionless. So this surface on y-axis, it's frictionless, but definitely in x-axis we have friction. While doing the problem, we'll take that into account. So let's try to solve the problem. All right. So here, definitely the step one, go with the free body diagram. So in this direction, I have this, I have weight mg. And if you look at, then so in y-axis, you have a force F sine theta. So my first equation turns out to be uh, my my double dot is equals to F sine theta minus of g. All right. Yeah. And here I can draw something like this and theta. So we will have F cos theta. So my mx double dot must be equal to F cos theta. So here I have my equation 1, here I have my equation 2, and now I need a constraint. So I have also a constraint equation here which says that x squared plus y squared equal to L squared. All right. So I'll take a derivative, and that goes as 2x dot plus 2y dot equal to 0 because this length is not changing. It's not extensible, you know, I mean, it's a rigid rod. So yeah. And now I'll take one more derivative, 2x double dot plus 2x dot squared plus 2y double dot plus 2y dot square, and this all goes to 0. Now, since I am calculating my acceleration at t equal to 0, so at t equal to 0, I have my x dot, that is velocity in x direction, and my velocity in y direction are both equal to 0, right? So I can definitely cancel out these two terms. So I'm left with 2x double dot plus 2y double dot, and this is equals to 0. So from here, I'll write that like definitely 2 and 2 cancels. And my equation goes as y double dot equals to minus of y by x. Okay, and just a second, let me do it properly. So yeah, yeah. So it goes as okay. Anyways, x double dot equals to minus of y, y double dot. Yeah. So this goes as like this. Yeah. This implies that x double dot is equals to minus of y by x, y double dot, and that is equals to minus of tan theta, y double dot. All right. So this is one more relation that I have got. So let me put this as which equation number 3. So equation number 3, right? So now I have 1, 2, and 3. Let me write that down there. So equations that I have, the first one is my double dot is equals to f sine theta sine theta minus of mg. The second one I have mx double dot equals to f cos theta. The third one I have is x double dot equals to minus of tan theta y double dot. So with these three equations, I'm going to do my analysis further. Okay, so from this equation, I can conclude this one thing, that m y double dot plus g divided by sine theta equals to f. And from here, oh, I made a mistake right out here. Sorry, I'm really sorry about this. I forgot to add friction. Sorry. So, okay, so now that since I have added, I forgot to add friction, I'll do one thing. So, okay, this was f cos theta, and this was, and friction will oppose it right in this direction. So this should go as mu times g. All right, sorry for the mistake. Now that I have corrected it, minus of mu times mg. All right, it's all right. Okay. So again here, I'll correct this. So it goes as m x double dot plus mu g divided by cos theta is equals to f. All right, so now will I equate these two equations? So that goes as y double dot plus g upon sine theta is equals to x double dot plus mu times g divided by cos theta. All right, so yeah, so that goes as y double dot is equals to tan theta, tan theta, and x double dot will be written as x double dot will be written as minus tan theta y double dot plus mu times g minus of g. Yes, exactly. So my y double dot will be minus of tan square theta y double dot plus mu minus 1 into g. Okay, mu tan theta into g. Sorry. So that will be mu tan theta minus of 1 times g. And now this becomes y double dot equals to mu tan theta minus 1 into g divided by tan square theta. All right, tan square theta, sorry, plus 1. This is it. So this is my one equation. And now similarly on the same lines, x double dot equals to minus of tan theta y double dot. Correct. So that will be minus of tan theta mu tan theta minus 1 g divided by tan square theta plus 1. So now if you want to further simplify this expression, you can simplify it. So with this, I have achieved my goal to find the initial acceleration of each mass. So for the first mass, that is this one, I have my initial acceleration like given by this, and for my this mass over there on the ground, I have my initial acceleration given through this expression. All right, with this I end. Hope you review this problem and see you in the next video. Thank you.